JavaScript is a high-level, dynamic, untyped, and interpreted programming language. It has been standardized in the ECMA script language specification, alongside HTML and CSS. It is one of the three essential technologies of World Wide Web content production. The majority of websites employ it, and it is supported by all modern web browsers without plugins. JavaScript is prototype-based with first-class functions, making it a multi-paradigm language, supporting object-oriented, imperative, and functional programming styles. It has an API for working with text, arrays, dates and regular expressions, but does not include any I/O, such as networking, storage or graphics facilities, relying for these upon the host environment in which it is embedded. Despite some naming, syntactic, and standard library similarities, JavaScript and Java are otherwise unrelated and have very different semantics. The syntax of JavaScript is actually derived from C, while the semantics and design are influenced by the self and scheme programming languages. JavaScript is also used in environments that are not web-based, such as PDF documents, site-specific browsers, and desktop widgets. Newer and faster JavaScript virtual machines and platforms built upon them have also increased the popularity of JavaScript for server-side web applications. On the client side, JavaScript has been traditionally implemented as an interpreted language, but more recent browsers perform just-in-time compilation. It is also used in game development, the creation of desktop and mobile applications, and server-side network programming with runtime environments such as Node.js. History. Beginnings at Netscape. JavaScript was originally developed in 10 days in May 1995 by Brendan Eich, while he was working for Netscape Communications Corporation. Indeed, while competing with Microsoft for user adoption of web technologies and platforms, Netscape considered their client-server offering a distributed OS with a portable version of Sun Microsystems or Java, providing an environment in which applets could be run. Because Java was a competitor of C++ and aimed at professional programmers, Netscape also wanted a lightweight interpreted language that would complement Java by appealing to non-professional programmers, like Microsoft's Visual Basic. Although it was developed under the name Mocha, the language was officially called LiveScript when it first shipped in beta releases of Netscape Navigator 2.0 in September 1995, but it was renamed JavaScript when it was deployed in the Netscape browser version 2.0 B3. The change of name from LiveScript to JavaScript roughly coincided with Netscape adding support for Java technology in its Netscape Navigator web browser. The final choice of name caused confusion, giving the impression that the language was a spin-off of the Java programming language, and the choice has been characterized as a marketing ploy by Netscape to give JavaScript the cachet of what was then the hot new web programming language. There is a common misconception that the JavaScript language was influenced by an earlier web page scripting language developed by Nombas named C, not to be confused with the later C, created in 1997. Brendan Eich, however, had never heard of C before he created LiveScript. Nombas did pitch their embedded web page scripting to Netscape, though web page scripting was not a new concept, as shown by Vylor. Nombas later switched to offering JavaScript instead of C in their Scriptease product and was part of the TC39 group that standardized ECMA script. Server-side JavaScript. Netscape introduced an implementation of the language for server-side scripting with Netscape Enterprise Server in December 1995, soon after releasing JavaScript for browsers. Since the mid-2000s, there has been a resurgence of server-side JavaScript implementations, such as Node.js. Adoption by Microsoft Windows script technologies including VB Script and JScript were released in 1996. JScript, a reverse-engineered implementation of Netscape's JavaScript, was released on July 16, 1996 and was part of Internet Explorer 3, as well as being available server-side in Internet Information Server. IE3 also included Microsoft's first support for cascading style sheets and various extensions to HTML, but in each case the implementation was noticeably different to that found in Netscape Navigator at the time. These differences made it difficult for designers and programmers to make a single website work well in both browsers, leading to the use of Best Viewed in Netscape and Best Viewed in Internet Explorer logos that characterized these early years of the browser wars. JavaScript began to acquire a reputation for being one of the roadblocks to a cross-platform and standards-driven web. Some developers took on the difficult task of trying to make their sites work in both major browsers, but many could not afford the time. With the release of Internet Explorer 4, Microsoft introduced the concept of dynamic HTML, but the differences in language implementations and the different in proprietary document object models remained, and were obstacles to widespread take-up of JavaScript on the web. Standardization. In November 1996, Netscape announced that it had submitted JavaScript to ECMA International for consideration as an industry standard, and subsequent work resulted in the standardized version named ECMA Script. In June 1997, ECMA International published the first edition of the ECMA 262 specification. In June 1998, some modifications were made to adapt it to the ISO IEC 16262 standard, and the second edition was released. The third edition of ECMA 262 was published on December 1999. Development of the fourth edition of the ECMA script standard was never completed. The fifth edition was released in December 2009. The current edition of the ECMA script standard is 6, released in June 2015. Later developments. JavaScript has become one of the most popular programming languages on the web. Initially, however, many professional programmers denigrated the language because its target audience consisted of web authors and other such amateurs. Among other reasons, the advent of Ajax returned JavaScript to the spotlight and brought more professional programming attention. The result was a proliferation of comprehensive frameworks and libraries, improved JavaScript programming practices, and increased usage of JavaScript outside web browsers, as seen by the proliferation of server-side JavaScript platforms. In January 2009, the Commons project was founded with the goal of specifying a common standard library mainly for JavaScript development outside the browser. With the rise of the single-page web app and JavaScript-heavy sites, it is increasingly being used as a compile target for source-to-source compilers from both dynamic languages and static languages. In particular, Mscripton and highly optimized JIT compilers, in tandem with a SM.js that is friendly to AOT compilers like CodeMonkey, have enabled C and C++ programs to be compiled into JavaScript and execute at near-native speeds, causing JavaScript to be considered the assembly language of the web, according to its creator and others. Trademark. JavaScript is a trademark of Oracle Corporation. It is used under license for technology invented and implemented by Netscape Communications and current entities such as the Mozilla Foundation. Features. The following features are common to all conforming ECMA script implementations, unless explicitly specified otherwise. Imperative and structured. JavaScript supports much of the structured programming syntax from C. One partial exception is scoping. JavaScript originally had only function scoping with var. ECMA Script 2015 adds a let keyword for block scoping, meaning JavaScript now has both function and block scoping. Like C, JavaScript makes a distinction between expressions and statements. Dynamic typing. As in most scripting languages, types are associated with values, not with variables. For example, a variable x could be bound to a number, then later rebound to a string. JavaScript supports various ways to test the type of an object, including duck typing. Object-based JavaScript is almost entirely object-based. JavaScript objects are associative arrays, augmented with prototypes. Object property names are string keys. They support two equivalent syntaxes: dot notation and bracket notation. Properties and the values can be added, changed, or deleted at runtime. Most properties of an object can be enumerated using a for in loop. JavaScript has a small number of built-in objects such as function and date. Runtime evaluation. JavaScript includes an eval function that can execute statements provided as strings at runtime. Functional first-class functions. Functions are first-class, they are objects themselves. As such, they have properties and methods, such as call. A nested function is a function defined within another function. It is created each time the outer function is invoked. In addition, each created function forms a lexical closure. The lexical scope of the outer function, including any constants, local variables and argument values, becomes a part of the internal state of each inner function object, even after execution of the outer function concludes. JavaScript also supports anonymous functions. Prototype-based object-oriented programming. Prototypes. JavaScript uses prototypes where many other object-oriented languages use classes for inheritance. It is possible to simulate many class-based features with prototypes in JavaScript. Functions as object constructors. Functions double as object constructors along with their typical role. Prefixing a function call with new will create an instance of a prototype, inheriting properties and methods from the constructor. ECMAScript 5 offers the object.create method, allowing explicit creation of an instance without automatically inheriting from the object prototype. The constructor's prototype property determines the object used for the new object's internal prototype. New methods can be added by modifying the prototype of the function used as a constructor. JavaScript's built-in constructors, such as array or object, also have prototypes that can be modified. While it is possible to modify the object prototype, it is generally considered bad practice because most objects in JavaScript will inherit methods and properties from the object prototype and they may not expect the prototype to be modified. Functions as methods. Unlike many object-oriented languages, there is no distinction between a function definition and a method definition. Rather, the distinction occurs during function calling, when a function is called as a method of an object. The function's local this keyword is bound to that object for that invocation. Implicit and explicit delegation. JavaScript is a delegation language. Functions as roles. JavaScript natively supports various function-based implementations of role patterns like traits and mixins. Such a function defines additional behavior by at least one method bound to the this keyword within its function body. A role then has to be delegated explicitly via call or apply to objects that need to feature additional behavior that is not shared via the prototype. Chain, object composition and inheritance. Whereas explicit function-based delegation does cover composition in JavaScript, implicit delegation already happens every time the prototype chain is walked in order to, e.g., find a method that might be related to but is not directly owned by an object. Once the method is found, it gets called within this object's context. Thus, inheritance in JavaScript is covered by a delegation automatism that is bound to the prototype property of constructor functions. Miscellaneous runtime environment. JavaScript typically relies on a runtime environment to provide objects and methods by which scripts can interact with the environment. It also relies on the runtime environment to provide the ability to include, import scripts. This is not a language feature per se, but it is common in most JavaScript implementations. JavaScript processes messages from a queue one at a time. Upon loading a new message, JavaScript calls a function associated with that message, which creates a call stack frame. The call stack shrinks and grows based on the function's needs. Upon function completion, when the stack is empty, JavaScript proceeds to the next message in the queue. This is called the event loop, described as run to completion, because each message is fully processed before the next message is considered. However, the language's concurrency model describes the event loop as non-blocking. Program input/output is performed using events and callback functions. This means, for instance, that JavaScript can process a mouse click while waiting for a database query to return information. Variadic functions, an indefinite number of parameters, can be passed to a function. The function can access them through formal parameters and also through the local arguments object. Variadic functions can also be created by using the bind method. Array and object literals. Like many scripting languages, arrays and objects can each be created with a succinct shortcut syntax. In fact, these literals form the basis of the JSON data format. Regular expressions. JavaScript also supports regular expressions in a manner similar to Perl, which provide a concise and powerful syntax for text manipulation that is more sophisticated than the built-in string functions. Vendor-specific extensions. JavaScript is officially managed by Mozilla Foundation, and new language features are added periodically. However, only some JavaScript engines support these new features. Property getter and setter functions. Conditional catch clauses. Iterator, protocol. Shallow generators, coroutines. Array comprehensions and generator expressions. Proper block scope via the let keyword. Array and object destructuring. Concise function expressions. EXPR. ECMAScript for XML, an extension that adds native XML support to ECMAScript. Syntax. Simple examples. Variables in JavaScript can be defined using the var keyword. Var x defines the variable x. The special value, undefined, is assigned to it by default. Var y equals 2 defines the variable y and assigns the value of 2 to it. Note the comments in the example above, both of which were preceded with 2 forward slashes. There is no built-in I/O functionality in JavaScript. The runtime environment provides that. The ECMAScript specification in edition 5.1 mentions. Indeed, there are no provisions in this specification for input of external data or output of computed results. However, most runtime environments have a console object that can be used to print output. Here is a minimalist Hello World program. Console.log, a simple recursive function. Function factorial. If return 1, return n asterisk factorial. Anonymous function syntax and closure example. Var display closure equals function return plus plus count. Var inc equals display closure returns 1 inc returns 3. Variadic function demonstration. Var sum equals function x plus equals arguments I return x. Sum returns 6. Immediately invoked function expressions allow functions to pass around variables under their own closures. Var v equals 1. Var get value equals return function v equals 2 get value of 2 numbers asterisk function LCM calculator constructor function var checkint equals function in a function if throw new type error throw an exception return x this a equals checkint semicolons caret are optional. LCM calculator dot prototype equals object literal constructor. LCM calculator when reassigning a prototype set the constructor property appropriately. GCD function b equals math.abs t if swap variables t equals b equals a equals t while t equals b equals a%b a equals t. Only need to calculate GCD once. So, redefine this method. Also, GCD GCD this, GCD this dot GCD this, GCD equals function or single quotes. LCM function asterisk this b only need to calculate LCM once, so redefine this method. This dot LCM equals function return LCM calculator a equals plus this a plus b equals plus this b. Define generic output function. This implementation only works for web browsers. Function output document.body.appendChild document.body.appendChild. Note: arrays mapper defined in JavaScript 1.6. They are used here to demonstrate JavaScript's inherent functional nature. 25, 55, 21, 56, 22, 58, 28. 56. Map array literal plus mapping function return new LCM calculator sort with this comparative function return a.lcm for arc output plus LCM equals plus obj.lcm. The following output should be displayed in the browser window. LCM calculator a equals 28, b equals 56, GCD equals 28, LCM equals 56, LCM calculator a equals 21, b equals 56, GCD equals 7, LCM equals 168, LCM calculator a equals 25, b equals 55, GCD equals 5, LCM equals 275, LCM calculator